Question 7 of the C4 paper in 2016, and it's our differential equations question. It's a big 9-marker, and it's a little bit juicy. Got some nice algebra in it. If you take your time, it shouldn't present too many problems though. A couple of things to point out straight away. First of all, it's a rate of decrease, so it's going to be a minus, and it's directly proportional to v cubed. Okay, so our dv by dt, our rate of decrease is proportional to minus, representing the decrease, v cubed. And then, of course, we swap the proportionality sign for an equals k. So dv by dt equals minus kv cubed is our first mark, our differential equation satisfied by v. Right, now they show us where we are going. It says, given that the initial value of the car is a, show that. Okay, so initial value means t equals 0, etc. First of all, we need to separate and integrate and create an equation. So let's separate and integrate and get v on the side with dv and everything else on the side with dt. So that v cubed will come over as a 1 over v cubed, which I've written as v to the minus 3, and that dt comes up there. Let's integrate that. The integral of v to the minus 3 is minus a half v to the minus 2, or minus 1 over 2v squared. And of course, the integral of minus k with respect to t is minus kt. And don't forget to add on your plus c, your constant of integration. They tell us that the initial value is a. So when t equals 0, v equals a. So that eliminates this bit here. That allows me to say minus a half over a squared equals c. So I can rewrite this expression again now, but swap c for this. So I now have minus 1 over 2v squared equals minus kt minus 1 over 2a squared. We are nearly there. Not quite as it shows on the exam paper yet. Let's reciprocate everything and tidy it up. I get 2v squared equals 2a squared over kt plus 1. Divide it all by 2. This is just a constant k, and we're going to divide it by 2, and they want us to call it letter b. Okay, so that gets me down to what they asked for. V squared equals a squared over bt plus 1. So that was the first 5 marks. So even if you didn't get this bit out, you should have still used this then to get the final 4 marks. It isn't difficult. It's just a little bit of algebra. The question says, when t equals 2, the value of the car has fallen to half of its initial value, which was a. Okay, now by using that, we will be able to get a value for b, right? So at t equals 2, v equals a half a. So I'm looking at this here now. I'm going to swap that for a number 2 to give me 2b plus 1, and I'm going to swap that for half of its initial value, a half a, and it'll be all squared. A half squared is a quarter, and then I bring that 2b plus 1 up over here as a multiply, and I'm left with an a squared on the left and an a squared on the right, and of course I can just cancel them, making it disappear off the left and turn it into a 1 on the right. Okay, take that that quarter up over there as a 4. I'm left with 2b plus 1 equals 4. Take the 1 over, get 3. 2b is 3, b is 3 over 2. That's 2 of the 4 marks. The question then asks, find the value of t when the value of the car will be a quarter of its initial value. So now, going back to this original expression we calculated up here, I need to find this value of t when this is 1/4 a. So 1/4 a all squared equals a squared over 3t over 2, as we've calculated b is 3 over 2, plus the 1. And then it's just a little bit of tidying up and a bit of algebra. We'll do it similarly to how we did it here. 1/4 squared is 1/16. And I'm going to bring this 3t over 2 plus 1 over to the other side as a multiply. It's got an a squared next to it, and I've left the other one over there. They will cancel, and that will become a number 1. Okay? So I've effectively got 3t over 2 plus 1 equals 16, because I've brought this 16 over and multiplied it to the 1. Take the 1 over, multiply by the 2 first. I've multiplied by the 2 first and left with 3t plus 2 equals 32. I've took the 2 over, becomes 30. 3t is 30. T equals 10 years. And when it comes out as a nice easy number than that, I feel pretty good about it. 9 marks in the bag.